Hi, I'm Kason Klarman, and this is my lab report for Physics 1. This lab focuses on exploring motion in real life and comparing them to the equations and models that we have used in class. In particular, we are focusing on constant velocity. Before we started the lab, our group hypothesized that after a small push to the side of the cart will accelerate for a short period of time, then travel with constant velocity before reaching the end of the track. This hypothesis is based on a few key assumptions. Number 1, the force due to friction is not present between the cart and the rail. Number 2, all air resistance between the cart and air is negligible. Number 3, we treat the cart as a single point rather than a complete object. These assumptions are important because if friction or air resistance is present, the cart will decelerate over time, resulting in a non-constant motion. Treating the car as a point is important for the later simulation, however. This entire hypothesis is based off the principle of Newton's second law, which states the acceleration of an object is directly proportional to the net force acting on it. Since, in our experiment and prediction, the net force on the object is zero, as there is no friction, therefore the cart shall proceed with no acceleration and constant velocity. In our experiment, we declared the system to just be the cart, while the surroundings are the hand that pushes the cart, the earth that acts on it, and the rail that it rides on. The cart begins at rest at the origin. Our procedure is to, number 1, apply a small push to one side of the cart. Number 2, record a video of the cart in motion. And number 3, use Tracker to analyze the motion of the cart. We also chose that the right is the positive x direction. This is a video of our cart in motion. We plotted its position for every 0.033 seconds, where we used the slope of the line between the beginning and end to find the average velocity of the cart, which was 0.35 meters per second. Using this average velocity, we plugged it into the code that we made to run the simulation. Here, we set the velocity vector to 0.3500 meters per second. The 0.35 is acting in the x direction and 0 in the y and z direction, as there are no forces that acted on it to set it into motion, nor an initial velocity in either direction. The net force is set to the vector of 0, 0, 0 as well, because there is no net force acting on the object. Here we have the velocity update formula, which is staying constant because there is no net force acting on the object to change the velocity. Here we have the position update equation. The ball's position is being updated and changed by the ball's velocity times the change in time. Here we have the time update to help keep track of where the ball is. Finally, the code prints it out and is shown as our graph. The observed versus actual graphs were almost identical, leading to our conclusion that we successfully simulated constant motion and that our assumptions were correct, that there were no net forces acting on the cart. Finally, our what-ifs. The change in axis would only affect the sign of our position and velocity, leading to a downward sloping position graph and a negative velocity graph if we chose right as the negative x-axis. We can also assume that in the x direction there were 0 pushes or pulls acting on the cart, while it was in motion, as the velocity was constant. In the y direction, we can also assume the net force is 0. For the y-axis, the force of the earth on the cart is counteracted by the force of the cart on the earth, summing the net forces in the y direction to be 0 with 2 pushes. Thank you.